Hello, it's Mr. Colati, and today we're going to be looking at 5.7 thermal energy. This section, there's a lot of slides to go through, a lot of definitions and physics concepts to learn. So there's not a lot of problems that go with it, but we will just talk about the unit conversions here. So we have always known the Celsius scale. This is how we measure temperature in Canada. The United States and some other countries use the Fahrenheit scale. It's a slightly different scale. Not only is it starts at a different number, but the degrees are a different amount. So 1 degree Celsius is not the same as 1 degree Fahrenheit. You don't need to know how to convert between these two for the course. I would never ask you to do that on a test, but the conversion is here. To convert from Celsius to Fahrenheit, you basically multiply by 1.5 and add 32. This is kind of the quick shortcut if you need to figure it out. One useful thing to remember in life is that freezing in America, or freezing in a Fahrenheit system, is 32 degrees, where for us it's 0 degrees. For a hot day in the United States would be 100 degrees, whereas Canada, well, 100 degrees C is when water boils, so you definitely would hope the temperature never gets up that high. Now we learned a third type of scale, which is the Kelvin scale. The Kelvin scale starts at absolute zero kelvins. This is the coldest theoretical possible temperature. We've never actually found or been able to produce 0 degrees Kelvin. It's very theoretical, but that would be when basically the little particles inside something stop moving. The good thing about the Kelvin scale, though, each degree Kelvin is the same size as a degree Celsius. So if you go up 1 degree in the Celsius scale, you're going up 1 degree in the Kelvin scale. You really need to remember this one number, 273. That's the number, the temperature in kelvins when water freezes. So our 0 degrees is equal to 273. If you can remember that, and you would need to remember this for a test, then you can do your conversions between Celsius and Kelvin. So, for example, mercury is one of two metals that is a liquid at room temperature. This is pretty neat, right? It's when you get mercury, it is a liquid at room temperature. When does it freeze into a solid? Well, at 38 degrees C. If I wanted to convert this into Kelvin, then I need to, 0 degrees C, I have to add a bunch to get the Kelvin equivalent. So similarly here, to figure out what this is in kelvins, I have to add a large number to it. So the temperature in Kelvin is equal to 38.83 plus 273. 38.83 plus 273. And so we get 312 Kelvin, because we need to consider our significant figures. We can only have as many decimal places. When we're adding and subtracting, we can only have as many decimal places as the worst number. This number, 273, has no decimal places, so our final answer has no decimal places. 312 degrees Kelvin. Okay, Mars has an average temperature of 293 during the day and 200 during the night. What are these in Celsius? Well, this is the opposite. If I gave you a number in Kelvin, 273, to get that back to what it is in Celsius, you have to subtract a large number. Subtract 273. So we have the temperature in Celsius of, let's call it the high number. That's going to be the day, I guess. 293 minus 273. That gives me 20 degrees C. Wow, that's about the same as Canada in the spring, 20 degrees C on Mars. So it's not a bad temperature during the day. The temperature in Celsius during the night, so the low temperature, is going to be 200 minus 273. And that gives me minus 73 degrees C. So there's a big problem if you wanted to travel to Mars. Beautiful during the day, but at night it's unthinkably cold. So something to consider if you're planning a vacation there. Make sure you pay special attention to all the concepts in this section, especially some of the words that are a little different in the physics world. Temperature and heat. And make sure you're familiar with those two terms. And yeah, we'll see you next time.